All right. Hi, everybody. My name is Todd Rosedahl. Work for Jabil, and Tim Lambert here joining us from Dell, and Phillip Leech from HP. And we're going to talk to you guys about plug and play. So if you're just at the last session, we hinted at it. There were some good ideas floated about how to do plug and play with that bridge controller. And we're going to kind of take a deeper dive into plug and play and where we're at, and tell you the sort of the roadmap that we see. Yeah, so first I'm going to do the overview of, what are we trying to do, why are we trying to do it, and this also might seem obvious, but what we want to be able to do is take off-the-shelf pieces and mix and match multiple HPMs. You can take an HPM from vendor A, put it in your MHS chassis with a certain DC-SCM. Similarly, maybe you want to put a new SCM in your chassis and just have this boot and work. That would be it. That's kind of the holy grail, what we're trying to get to. And that's really going to help with certain things. I have a few favorite sort of use cases, and one is security. So if you have a system, you have your own security in a cloud provider, you can buy an MHS chassis with an HPM. You put your own SCM in there because you don't trust anybody else's SCM. Put yours in there, and now you can have your security. Similarly, that would help it just fit seamlessly into your systems management structure, because you buy a server from A versus B versus D, there are always differences. Even though we're trying to standardize that with things like Redfish, there's always uniquenesses. But if you would have your SCM on there with your code, that's going to be much easier to integrate with with the systems management stack. It's going to be cheaper. Another good thing I like is, as you go generationally, like if you're doing bring up, or even maybe not even bring up, you can just update your compute. Grab a new HPM, one that's later, maybe has some better memory on it, maybe it's faster, as long as it fits in the power and thermal envelope. You put that in and upgrade your infrastructure, whether you want to do it in production or even just in the lab. That's just going to help time to market and just help everything move faster, which we all want to be doing. Yeah, okay, go to the next one. All right, so then what are the challenges with this? And again, we were hinting at this somewhat in the last session, but if you have a silicon from different vendors, you have different HPMs, this BMC then needs to know how to talk to that. You need to know how to talk to that silicon, you need to know how to configure everything, and that's sort of a big ask in a single BMC image. So there are problems. So I'd like to think about this. There are a lot of things you need to worry about, but I'd like to think about just temperature sensors, because it's just so simple. Everybody can kind of grasp that. You've got a temperature sensor, it's on a board, and your BMC code knows how to read it and what it means, what to do with it. Put it in a different board, and now you don't know, where's the temperature sensor, what bus is it on? And even if you would know that, what kind of, what do I do with that temperature? What does it mean? Do I shut down? Do I raise my fan speeds? So when you think about this as in those terms, it makes it sort of simpler. So we'll go to the next page. Okay, yeah, so what are the options to solve this? And so all of these will be used for some of these problems. We do each of these methods. So one would be standardization. So for this temperature sensor, again, you could say this sensor, they all have to have a sensor at a particular spot, this type of sensor, and that we have to do that for some things. We have to do that for discovery of the HPM, for instance. On bus, whatever, you have to have some device so you know what that HPM is. But that's not really practical to do for everything. It would kill innovation, and it's really not overall a good method for all of these different things that we have to have knowledge inside the BMC. You can, number two, you can certainly have BMC code that understands that HPM. So the BMC would come up, oh, it's this type of HPM. I put a new load on, and I can operate differently. And now I know about the temperature sensor. I know about all these I/O things and how to configure them. But that really is not in the spirit, right? That's co-design. That means that BMC code was written with the knowledge of that HPM, deep, intimate knowledge. We don't really want that. We want it to be much simpler. The BMC is a small load. It doesn't have to have all that knowledge, and it's able to still do plug and play without understanding a priori what is in that HPM. Third thing is we can discover devices, and this is also true. You can use I2C detector things. You could walk the bus, and you could find the temperature sensor. And that's good. Now you still don't really know how to read it, and so you have problems there. And what you really don't know is, what do I do with that temperature? What does that temperature mean? I see 10 temperature sensors. What am I supposed to do? What are the trip limits? How do I know how to operate? What fan speeds do I need to go to? How do I shut down? Or when do I shut down? all of these are problems that we think the way we're going to go is these HPM definition files. So that is what we're working towards. This is where this file or files will be created by the HPM vendor. They would be, because the HPM vendor, they understand everything about the HPM. So they're able to write this file that says, oh, here's the temperature sensors on me. Here are all my different devices. Here's how you configure me. And then that's a file that just gets read by the BMC. And now the BMC, now it knows everything about the HPM, how to configure everything, read everything, what the trip limits mean. So this is kind of what we're looking at doing, and we think that would really help the integration of all these various HPMs. And Tim's going to take us through the roadmap here.
Yeah, so about 5 years ago, there was a presentation called DC Stack, which thought we could jump straight to plug and play. So we've had to build up from the first pass of DC-MHS was all card electromechanical specs, interfaces, and provisions for a safe detection. You can plug and detect or halt if you don't know what you are at a model level. And there was really no reuse or guaranteed hardware or firmware interop. It was kind of, it's a good stepping stone. Through this past year, we've already said that we've moved into the plug and code, where we've been able to start attacking the logical domain. So we created these HPM common circuits, type 1 and type 2, that give the biggest swath of the market that we could find that addresses the most situations. We know there could be a type 3 or type 4 if new pockets of different markets have specific needs. And what these do is it goes from a menu of options of types of things you can use through the interface to the one function per pin kind of. This is how commonly people do it, and it's really taking off and making new HPMs be able to have less questions about how to achieve that interoperability. The logical domain is working quite well. The electrical domain still needs some work to get to, say, PCI SIG level compliance kind of thing, so you know that you have the right capacitance, we have voltage and we have domain when you can engage buses and things of that nature, but it still needs some more in that electrical to guarantee 100% that you know that you're going to be able to reach the bus, the capacitance on an I2C bus, for example, or the pull-up resistor value, things like that. So we feel that we're at plug and code today, minus some more electrical low-level compliance work that needs to get done. So we've kicked this up as last year we called it Journey to Off-the-Shelf HPMs, but we've now extended that also to include peripherals because we think that there's could be a market for risers, backplanes, and things of that nature, and how you go about discovering them, configuring them, and managing them. So we want to be able to ingest, with your SCM, we want to be able to ingest new HPMs and peripherals. So we set up this thing around device classes and vendor IDs and stuff, mimicking, those that went before us and specs like PCI SIG and USB and whatnot. And so we're kicking this off now. We know it's a long journey. We have published the 0.3. It's on the site at this point. Phil's going to go much deeper into it. We're calling it Plug and Play Light because we know this is a journey. But I think in this past year, we've gotten a very, very good progress. And then we know this will grow over time so that ultimately when you get to that full plug and play, we can then start thinking about more of these hardware, software, co-design sort of automation things, where imagine a world where you have the bill of materials, the net list, the board file, and you're able to automatically create your Linux device tree out of that. And you're do governance and verification testing that this is exactly what you did want, with no human involved for setting up all these sensors and GPIOs. You may laugh. Some of us already do this, and we're trying to do it at a wider ecosystem level. And then also applying AI techniques to that as well, clearly. All right, and then Phil's going to go into more of the nuts and bolts of how we're accomplishing this.
All right. Thanks. I'm Phil Leech, work for HPE. So really, what is this work stream that we've been working on for the last year? It's called Modular, the Modular Plug-n-Play. The idea is let's really try to standardize and relieve the burden on system firmware bias in order to ingest those HPMs and peripherals. So as we were working through this, we identified a key set of deliverables which we think we're bundling as a specification package. And that's what Tim had just alluded to here. We just released this last week, a 0.3 specification package. And in that, we've got the FRU Discovery boot spec. And why does it have this long name? Because it started off as 3 separate specs. We realized quickly after working, over the course of several months that, well, the FRU, that's great that we're defining a new FRU EEPROM, but why do you even need that data? Well, you need it for discovery. You needed to discover the HPM and all the peripherals in your system. And then the next spec after that is FPGA. And then FPGA is separate because it's just so much more complex than, and we couldn't combine that together into one, otherwise you'd have a 1,000-page specification. And finally, we've got something called the interop spec. And what that's there for is to sort of act as the glue of all the other specs, define conformance, define criteria in order to say, well, how do I measure interoperability between components? And all these are at 0.3. There's a lot of detail. So I'm going to give you one click down into these specifications just to give you an idea about it. But I encourage everybody who's interested, please go look at these specs because we are, we want to get feedback because we think we're on the right path. We're not 100% sure, so we'd love to hear your feedback. Okay, so what is the FRU Discovery boot spec? Well, first of all, we said, what's the first thing that the SCM needs to do? It needs to discover the HPM. It needs to go figure out what are all the different buses, interconnections, the devices. Once you've got that inventory, well, then how do you configure those devices? So we said, well, what's needed is some additional data in the FRU. In the FRU EEPROM, what we're calling is it's a self-describing JSON file. Why did we choose JSON? Well, that's pretty common, and also we can leverage Redfish. So the idea with this is each of these devices, the HPM, risers, backplanes, PDBs that have a FRU will have additional data that basically creates a map of the various devices, the bus trees, like your complex I2C tree with muxes and et cetera, and give you the what's necessary to control those different muxes and other devices on the HPM or the components. And so last week we said, well, what are some boot requirements? Well, we're still working on that. It's probably the thinnest section in the spec because we focus so much on discovery and FRU over the past year, but we hadn't had too many ideas about boot other than maybe there's something unique that needs to be in there. We'd love to hear your feedback because hey, if I think some particular boot requirement needs to be in there, something in the boot process, please let us know. We'll move on here. So I want to give you a little bit more detail about this FRU EEPROM. What did you add? What did you do? Well, so you've got your HPM type, the SCM the multi-record from the SCM 2.1 spec. That's in there. We didn't change any of that. What we did is we added an additional multi-record, and this multi-record is actually using the new DMTF FRU files format multi-record, and that's in this the DMTF org. Go to there's a whip out there that you can read. That spec will be available hopefully in the coming months here. But the idea is, we just point to that spec from a format perspective. What is it that we're providing is the details around the JSON self-describing data. We've got a whole bunch of sections with here's these attributes, here's these new fields, and we'd love to hear your feedback on it. I think we took a kitchen sink approach, and we've got a lot of things in there that, you would say, well, why do you even need that? Well, we don't know. We're just, hey, I think, a system integrator might want that data. But to a certain extent, we're going to have a minimum viable product version of that would have just the required attributes. And then essentially, that's what would be necessary for discovery. You can have these additional attributes in there, whatever you'd like. If you'd like to describe more interesting things, it's up to you. But we'll outline, here's the required attributes, here's the optional ones. And finally, we've got a digital certificate and a digital signature. We think that having it, signed and in there is mandatory. That's because we want to make sure that this FRU is not compromised. So we'd love to hear your feedback about that. Can we move on to the next there. So what about peripherals? Well, we're actually going to be using the same exact format. Essentially, we're going to have this peripheral M-PnP multi-record, which the only difference is, well, we expect it to be smaller because the peripheral doesn't have usually much, buses and things to describe. We are going to have a peripheral M-PnP multi-record that's going to provide a little bit of additional identifying information. That'll be fairly small too. But again, we would like the digital certificate and digital signature to be there, because what if you have a world where you might get a peripheral from one vendor, an HPM from another vendor, and you're the guy integrating all these things together? You'd like to know that it's secure and each one is not tampered with. All right. Here's a little bit more detail about the JSON. I know this looks like an eye chart. Don't worry. We actually have in the 0.3 package, we've got a mock-up for the HPM self-describing JSON file. We'd love for you to take a look at that. Comment on it. Tell us what we have right, what we have wrong. Like I said, that what we've got today is sort of throw in on the kitchen sink. It's got everything in there. All these attributes that you think might not be necessary. Well, probably most of them are optional. But we like to understand if perhaps you might have some other attributes you'd like to see added in there. We'd love to hear your feedback on that. We can go to the next one here. And then the FPGA specification. This one's particularly large, and this has got a lot of data, a lot of information on 0.3. The idea around this is we wanted to standardize all the various interfaces. We wanted to standardize protocols so that your BMC knows how to communicate with that FPGA. The things like, what should the SGPIO look like? What should it have a protocol, or should it just be basically just clocking bits? I mean, what should it be? So those are the kinds of things that we're trying to define. So for instance, SGPIO or LTPI, you got to pick one. You could pick both, but you got to choose one of those. Well, what if you need to get to the FPGA memory map to get to CSRs in the FPGA? Well, now you might need to have essentially a mailbox interface that's tacked along with the SGPIO with all the clock GPIOs. So those are the kinds of things that we're looking into. That's not in the spec today. We just have ideas about it. We're trying to figure that out as part of the future tasks that we're working on. But what is in the 0.3 is the framework. And the framework we think is very important because it gives you an idea of how do you, if I get to the FPGA memory map through like the LTPI data channel, well, we provide a directory structure so that okay, this is how I get to all the CSRs that, for this particular IP block or that particular IP block. Now what really, and this is the thing that's really important, what ties this all together is that the description of this will also be in JSON, and you will get that JSON either as an additional addendum file that goes with the FPGA image, or it's going to be in the FPGA itself that you will get to in the memory map, stored in a location that you can pull that JSON data, and obviously we'd want to probably have that compressed to really, reduce as much memory as possible, but pull that data back so that the BMC will know, without needing to have a priori something built in, it'll know how to use every single CSR, know where all the virtual wires are mapped, etc. So I know I've kind of said a lot. It's a lot to absorb, but so please take a look at that spec. We'd love to understand what are we doing right and what are we doing wrong. All right, now finally here in the interop specification, today in the 0.3 spec, we've got a sort of definitions, a vision. We have a definition of interoperability that we've agreed upon. We'd like to understand if the industry agrees upon that definition. And then sort of a directional language about what we like to have around conformance, interoperability requirements, et cetera. But the idea is this is the sort of parent overarching spec that sort of glues everything together. And essentially with this, it's going to reference a lot of supporting documentation and these other specs. All right, well, I'll let you go ahead. Thanks.
So this is where the big payoff happens around modularity. The faster time to market, the ingestion of new HPMs, the dynamic ability to create new device classes of peripherals, and how to learn and manage those so that it's not everyone duplicating the same exact thing, so that you can ultimately get time to market, regardless of how you get your firmware. So it was it was a mountain to start to tackle, but we felt we absolutely had to do this. in order to start this journey toward this automatic ingestion, automatic configuration, removing the human elements from the hardware design into the firmware implementation and the setup of the configuration. That the point 3 were largely some of the low-hanging fruit. We now have some bigger ones to tackle in the security domain and in the boot domain. Discovery is actually, it was, once you really started talking and opened it up, we all agreed that, yeah, we're all doing them very similarly, and we were able to very quickly lock in on, this all makes perfect sense on how we would do it, and it's all tied specifically to the DC-MHS types of interfaces. The way you configure flexible IOs and negotiate pin functions through these connectors that you've been seeing on the earlier presentations. And dynamically based on which types of device classes and vendor IDs and whatnot that you have there. So the boot and the discovery are very eclectic, or the security and they're very eclectic on the things and options that you can do. So we are really trying to take this framework approach to be able to make continued progress through that. We feel pretty proud about what we've done to get to the point 3 level, but the hill is about to start getting much steeper, and we absolutely would love your feedback on, are we moving in the right direction as implementers and people are having to know this just as well as everyone else. There's so much duplicated work to be able to bring these platforms online with full feature set, robust, and all the leverage points and opportunities that are out there. So, any questions?
That was so clear.
Yeah, this is child's play, right? Thank you very much.